Following solution walkthrough illustrates how organizations may utilize Equinix Metal and the Equinix Fabric to integrate with and extend the Volterra ADN without having to increase their on-premises footprint. To start with, let's take a look at how a client's connection to a published application flows through this solution. The Volterra ADN provides control plane functionality to the customer edge, enabling centralized management and configuration of customer edge sites, including DNS. To access the application from the internet, the client resolves the application hostname via DNS. The hostname will resolve to the public endpoint of the customer edge site where the application is exposed. For this solution, the customer edge, or CE, is a 3-node Volt Mesh cluster that has been deployed into Equinix Metal. By using Equinix Metal to host their CEs, organizations can interact with and consume Volterra services with their applications without having to expand their on-premises data center footprint. From there, the CE will proxy the connection to the backend origin pool members. For this example, we have placed our origin pool members in GCP. To reach the backend origin pool, I will establish a private connection between our Equinix Metal hosted CE and the backend origin pool using the Equinix Fabric. Currently, the Equinix Fabric supports A to Z connectivity with Equinix Metal. In other words, the Equinix Metal site is a destination endpoint and cannot initiate connectivity. To address this limitation, however, the solution makes use of a Cisco CSR 1000V router instance. This is deployed in the Equinix network edge. Connections are established between both Metal and GCP environments to the Equinix Fabric by means of the Cisco router, providing end-to-end routing between the CE nodes and the origin pool members. For the remainder of this video demonstration, I'll walk through the steps that are required to establish this end-to-end connectivity across the Equinix Fabric. The first thing I'm going to do is establish a connection from Equinix Metal to the Equinix Fabric. I'm going to request a new connection, specify a location. I'll be using Dallas for this example. I'll provide a connection name. For this example, I'll select a single connection. Once the connection request is approved, a notification will be sent to me. As the example shows, a connection has been provisioned. I'll need to make note of the UUID, which will be referenced in the next step. With the Equinix Metal side configured, I will now turn my attention to the Equinix Fabric side. From the Connections tab, I'm going to choose a new connection. I scroll down and select Equinix Metal. For the connection type, I once again have the choice of a single or redundant connection. I'll go ahead and choose a single connection. To establish the connection from Metal to Equinix Fabric, I'll need to utilize a network device. In this case, I'll be utilizing a Cisco CSR 1000V router, which has previously been deployed on the Equinix network edge. This will address the A to Z connection limitations and provide for end-to-end connectivity from Equinix Metal to Equinix Fabric. For this demonstration, I've already deployed the router and configured it to use BGP. I'll give the connection a name and provide the UUID token included in the email I received previously. After a quick review of the connection summary page, I can submit my request. I now have connectivity established between my Equinix Metal hosted CE cluster and the Equinix Fabric. With the Metal side now connected to Equinix Fabric, I'll turn my attention to connecting GCP. From the GCP console, I navigate to Platform Hybrid Connectivity and Cloud Router. I need to do a couple things in GCP. I need to create a cloud router. The cloud router's job is to provide the ingress-egress endpoint for my hybrid connections. The cloud router itself can be attached to numerous VPCs requiring hybrid connectivity. To create the router, I need to give it a name, specify the VPC, the region, the Google ASN number provided by Google. I'll advertise all subnets and click Create. With my cloud router created, I'll need to create a VLAN attachment. I'm attaching my GCP VPC to the cloud router, which will enable point-to-point connectivity between my VPC resources and the other end of the connection, which will be the Equinix Fabric in this instance. I'll choose the interconnect type, and since we're connecting the Equinix Metal cluster through the Equinix Fabric, I'll select Partner Interconnect Connection. The pane on the right provides me with the summary of the steps I am performing. I'm going to connect to a single VPC. I do have the option to associate multiple VPCs for redundancy. I specify the VPC and the region. Select my previously created cloud router, give the Vlan attachment a name, optionally I can specify the MTUs, and click Create. With that created, I'm presented with a pairing key. Similar to the UUID used previously, I'm going to make note of and use this pairing key back on the Fabric side to create the connection. Back on the Equinix Fabric portal, I'm going to create a new connection just like I did before, only this time I'm going to scroll down and select GCP. I have a few different options for my Google connection. I'll select Partner Interconnect Zone. The zone selected is determined by the pairing key generated in GCP. Once again, I've created a VLAN attachment in GCP. I need to create that connection on the Fabric side as well. We're doing that. Much like how I configure the Equinix Metal side, I'll select how I'm connecting on the Fabric side. I'll specify the same Cisco CSR 1000 that we previously deployed as well as the region. Give the connection a name. Enter the pairing key that was generated in GCP. I'll select my desired connection speed based upon need and budget. Choosing Next once again gives me a little rundown of the connection details. With that completed, I now have my connection configuration complete for both GCP as well as Metal. Clicking on one of the connection images presents me with details and status for the connection, including bandwidth, latency, etc. Now that I've connected our Equinix Metal hosted CE cluster to Fabric, our GCP VLAN to Fabric, and have my Cisco router configured for routing between the two using BGP, I can validate my end-to-end connectivity. I'll start with by testing client connectivity from the browser. You'll notice every time I refresh the page, a new pool member responds. Likewise, the Vault Mesh node IP, which equates to the private addresses of my CE cluster, updates as the traffic is spread across the cluster. Next, I'll view the Volterra Console. Let's take a look at the load balancer. The load balancer dashboard provides me with various pieces of information, including health score, latency information, HTTP error codes, request information, etc. Taking a look at my actual backend pool members, I can view the pool member stats as well as verify the member addresses. To conclude, I'll scroll down and view my HTTP request metrics, as well as verify the public-facing VIP address corresponds to my advertised application DNS entry. With that done, my deployment is now complete.